welcome to the panel about the impact of academia on AI innovation. I am Gonçalo, co-founder and CEO at Data, Data-Centric AI workbench for data scientists, and I'm going to be the host of this panel. With me, I have three amazing guests, Mário, Che, and Stavros. Let's get to know them. Mário, care to start?
Sure. So I am Mário Figueiredo. I'm a professor of electrical and computer engineering, actually, at the IST, which is the engineering school of the University of Lisbon. And I've been teaching machine learning courses and information theory courses for a long time. And I also have the first, I guess, endowed chair in Portugal, which is called the FIDSAI Machine Learning Chair. And I also was sort of the founder and the first coordinator of our master program in data science. So maybe that's what's relevant now.
Continue, Chair.
Hi, everyone. I'm Che from ETH Zurich. I'm a assistant professor in the computer science department. My group work on many topics on machine learning systems. I myself have a background in data management. So one thing that we have been doing over the years is really try to bring together these two different areas. One on the data side, have a deep understanding about data quality, right, data integrity, and data scalability, right, and how to link them to machine learning and how can we make a difference. Yeah.
And hi, everyone. I'm Stavros Zervoudakis, assistant professor at New York University. I've been there for a bit over 8 years, taught a number of courses. In the last few years, I'm focusing on a course we call Applied Data Analytics, which is a 2-semester course. It goes from the basic stats and visualizations all the way to deep learning and transformers in 2 semesters. So in that course, we try to teach our students, of course, the theory and how they apply it, but at the same time, how they work in the industry with respect to potential data issues, being data-centric and focusing on solving business problems. These are tools that we use. So we try to provide practical knowledge and practice. At the same time, I am the head of AI at Mutual of America. It's a well-known corporation in the United States working in the retirement industry. I've been with the company for a couple of years, building the AI practice from the ground up across all verticals, vision, strategy, writing code, you name it. So I practice what I do and what I teach, and I teach what I practice. Pleased to be here. Thank you, Gonçalo.
Right. Well, my pleasure. Thank you all for being here. So first things first, and before deep diving into the session topic, let's better understand the overall role of academia in what regards technology transfer to the industry. So our three guests not only teach, but also hold different roles in the private sector. So can you better explain the relation between academia and the companies that we are either advising or working with? And why is it important to have such close ties with academia? Gonna pick this one first, Mário?
Sure, why not? So I've I probably should highlight the fact that I have this endowed chair, which was created by FIDSAI, which is a big company in Portugal. They're actually a unicorn, and I've been collaborating with them for quite a few years. And everything started by co-supervision of students to do work that was relevant both from a practical point of view for the company, but also challenging because it was cutting edge research in terms of machine learning, and from that's what's led to this very fruitful collaboration. I've been in some years now. I've been also advising a VC venture capital firm in Portugal called Faber Ventures, and I help them kind of assess the technical and scientific solidity of the companies that they're looking at. And for that, I think having a solid background in the theory and methodologies of machine learning and data science helps. It's easy for me to spot, say, weaknesses, technical weaknesses, and lack of solidity. So I've been trying to do that. I think at least in Portugal, maybe the time constants are different in other places. At least in Portugal, the scenario changed dramatically in the past decade. So I'd say that 15 years ago, in these areas, I'm not talking about all areas of science and technology, but I mean in data science, machine learning, I would say that 15 years ago, there was absolutely nothing interesting outside of academia. Now there's amazing things happening outside of academia, and it's pushing and pulling academia, and it's very important that academia does not lose the pace and keeps collaborating and helping these companies thrive and being successful, both by providing, of course, manpower, people, by educating young students and in these areas, but also collaborating directly, because most of these companies have a lot to learn, but also a lot to teach, and they're doing cutting edge research, and so it's very interesting and very stimulating to work with these companies.
And I continue on this one, Sarah?
Yeah, I totally agree, right? So in my opinion, so we have been working together with a whole bunch of companies in private sector. In our experience, this interaction between those companies and academia is always a win-win solution, right? So on one hand, the academia are going to produce the next generation of leaders, right? For the company, it's actually very important for company to tell academics what are the most important problems that you guys should focus on, and what are the type of leaders that you need to produce, right? So in the long term, right, so by working closely with academia, I think the industry get more and more better leaders in the area that they really need. I think that's really, really important, right? On the other hand, the academics will also have like more guidance, more signal from the market, right? So to really focus on things that actually matters to the real world. So I think if we want to maintain this kind of win-win situation, right, so it need to start from somewhere, right? So in our experience, it's often easier for the industry people to actually come in to actually tell academics, okay, these are our challenges. This is the thing we have no idea how to solve. Can we work together and make some progress on those, right? So I think this interaction is really, really important. Yeah.
And I would agree with both Chen and Mario. I would add to that based on my experience, and I had senior positions at other companies, Citigroup, and also with startups in the last decade. And I advise a few companies. I think the role of academia is critical. I have taught at boot camps, small boot camp kind of schools that they try to make data scientists overnight. And I can see the role of structured academia being more important now as everybody tries to become a data scientist and machine learning engineer, because there's a lot of demand, and it's quite interesting what we can do with these technologies. But in academia, in the structured university environment, you build on the knowledge, and that's what we do in my courses. I try to build from the ground up the theory, and then you apply it and bring real world experience to the classroom. At the same time, in my current job, we do hire interns, and we actually give them meaningful work. One intern I had in the summer, he worked on a project for the company on natural language processing. So he had the prerequisites. He knew Python that we use from his school, not my student, from another school. So we try to bring the practical knowledge to the classroom, because it's important for the next leaders that the academia produces. And at the same time, when we interact with students outside the classroom, to help them, be ready for the industry, be ready to take leadership roles in terms of not necessarily being an executive out of school, but in terms of leading, leading the practice of AI in the field, because many companies, unless you are a technology company, you have invested a lot in AI, the business team doesn't know what's possible. So we try to get the students to become leaders from the get-go, even if they are interns, to take ownership of what they do. And also, again, we teach that in the classroom. Yeah.
All right. This was very interesting. I have a couple of follow-on questions, actually. So Mario said that the environment in Portugal changed. I think that changed a little bit worldwide. And she also mentioned that you have close ties with the private sector, where the private sector expose challenge and problems that they are facing, and then we have academia trying to solve those problems. So do you think that because this is such an emerging technology, there are not that much talent in the market, the private sector is actually pushing the academia forward with this kind of demand? Or how do you see the relationship between academia and private sector working and actually improving over time?
Yeah, so I'm not sure I understand your question. Yeah, actually saying essentially, how does this relationship have been evolving over time?
If it's the private sector putting more demand into the academia so you can have more students, more incentives in research labs and so on, and how would this evolve over time?
Yeah, so that's actually a very, very interesting question. Yeah, I need more time to think about it if other panelists want to chime in, right? So
I would pitch in here. I would say that it improves the interaction between academia and industry because contrary to what was available 5 and 10 years ago, it was mostly research and just a few companies. Now it is, should I say, trendy. Everybody can understand that you can generate business value with this kind of technologies. So industry is reaching out to academia, and actually from my own hiring, we reach out to universities to see if we can get some students to hire, and that is a good step. However, I think there's a lot more to be done. I understand from small schools, boot camps, and perhaps some other schools that teach data science. They don't teach so much in a practical way. Maybe you do a couple of capstones, but not really something that perhaps could create the next startup. That's only done at Stanford and Harvard and this type of top universities. Of course, NYU is producing a lot of good skill set. We're top in data science, but I'm talking in general about academia and other schools that are just starting out with their data science and AI kind of teaching.
Yeah, I can just add a couple of words. So yeah, in what I can say, what's happening in Portugal is probably happening a bit around the world, is that the fact that it's clearly evident even to younger students, say teenagers just out of high school, and at the stage where they have to define what they're going to do next, it's clearly visible that there's a lot of demand for people in AI, data science, those kind of things. And we're seeing this in Portugal with a higher demand for students at the undergrad degree, for degrees, for programs that have this path towards that can lead to AI, data science, that kind of things. Yeah, and of course, in contrast, more traditional degrees such as civil engineering or mechanical engineering or even electrical engineering, which have a more traditionally sound name, are suffering a little bit from this competition. But that's the way it is. So in terms of another thing that's probably relevant in this day and age, which was different from what it was even just 10 years ago, is that the students have access to a whole huge amount of information online. You can learn online quite a lot, right? And most students, especially those who are more active, more proactive, they will exploit these two paths in parallel. They have their academic normal thing. They have to get grades to complete the courses, but they're also learning and going to GitHub and Kaggle and trying to learn on their own stuff. And that's very interesting because this is something that puts some pressure on academia to make itself a little more interesting. But I think academia should not blindly follow these because they have a different role, right? So the time constants involved in this kind of learning and the time constants involved in company work are much, much faster than time constants that are typical of academia. Like a PhD degree would take typically at least 3 years. In the US, typically say more like 5. Whereas things are moving so fast in machine learning these days. Like in January, we didn't have stable diffusion. Right now, it's just everywhere. And so I think it's a challenge to somehow make these two two environments that have very different time constants to be compatible with each other and to help each other, without losing their what is their most important assets of each of them, of course.
Yeah, I totally agree, right? So I think in the last at least like 5 or 10 years, so we see this lot of kind of positive influence the industry having on academia, right? So right now, right, many universities still have data science program, right, machine learning program, right? So start to react to the signals that we get from industry, right? So I think that's really positive change. But it's also agree that at some point we also need to think about these different roles that these two entities are playing together. But kind of optimistic that we will figure out something really amazing for the future, right? Yeah.
Right. Let me double down on one of the topics that you mentioned, which is a lot of startups are emerging and many students are learning other skills and launching their own startups. So actually in this realm regarding AI and data-centric AI more specifically, a lot of new startups have deep roots in academia. So my question is academia now driving innovation in this sector, or why are so many students actually, maybe some not even finishing the course, to launch their own startup? Can you explain us why is this happening, or what are your thoughts on this?
Yeah, so I can start, right? So essentially, so I wouldn't say it's academia driving the innovation. I would say because if you look at the problem we are trying to tackle, is ridiculously complicated, right? So we are dealing with huge amount of data. We need to start to have forming the idea, forming the technology, but all the way to bring that to people, to society, to have real impact, right? So we are really talking about this multi-stage type of process to really have something real, right? So I would say academia and industry and startups, they are actually driving innovations in different of those components that they do the best, right? So academia is good at forming ideas, right? Have proof of concept, right? Dream big about something crazy, right? But on the other hand, the help from the market, from startups to make them a reality is also important, right? So I see this as a multi-stage type of process, and different players are kind of driving innovation in different of those stages, right? So I think why you see so many startups have academia root is really because the problem we are trying to tackle, they really contain these multiple stages, and lacking any of the partners will be really hard to make a real impact to the world. That's my personal view on this.
And I would add to that we live at exciting times, that building a company is quite easy, and the use of data and the use of AI techniques can spark the imagination on students on creating a solution that will generate value, whether it is for consumers or for a business. So through the interaction in the classroom with other students and the professors, they may get ideas, even from a homework assignment. Yeah, I can take this and maybe sell it, create a business out of it. And that's how they get started. Of course, they need to have all the other pieces in place and a little bit of luck, and but it makes it easy. You don't have to have you're not in a brick and mortar kind of economic landscape. You can create a company out of nothing. You just have a little bit of computing and a little bit of data, and you can build on many ideas. And I think that's the main reason that we see startups coming out of academia. Of course, there are startups from people who have experience in the startup industry, creating a company and then selling it, or startups from other companies. But I think we're going to see a lot more, because it's easy to do it. It's easy to try an idea and see if it succeeds quickly. And if not, then your investment is not really a big loss if it doesn't succeed.
Yeah, I totally agree. So I think there are two components to this, say, easy nature, so that the how easy it is to create a startup now. On one hand, if we're thinking about, of course, machine learning, AI-based data science startups, not mechanical engineering, it's even like 15 years ago, if you wanted to use some machine learning data science components in a company, essentially you'd have to know the math and do it from scratch. And now it's easy, right? If it's something reasonably standard, it's easy. There's so much open source stuff. There's so many things out there that it's easy to build. And on the other hand, there's a cultural issue. Like everybody talks about startups now, right? And so it's kind of something that comes to mind, right? If you have an idea, it's natural to think, let's maybe think about doing a startup to make money with this, which is something which was not culturally present and prevalent, say even just 15 or 20 years ago or 10 years ago. Now it's everywhere, right? People admire all these big companies and unicorns, and there's so many people thinking of creating startups that it's natural. It's something that is now part of society. I mean, of course, Western societies.
And if I may add one more point, you can apply these techniques anywhere, any type of industry, any type of sector, any type of operational function of a company or organization. And once you have data and you have knowledge on how to apply these techniques, you can create a model, you can create a solution that includes models and generate insights that are based on AI and machine learning. So the landscape is enormous where you can apply these techniques. And we see that there's a lot of focus on language in the last couple of years and a lot of progress. Of course, vision is almost nailed it, computer vision. And there are many other things, robotic process automation. You can apply it anywhere that the company wants to invest in. So startups to create solutions that can be bought by companies or consumed by consumers are something that I would say many people would like to do.
Right. So the opportunities are there, and we need our students to seize the opportunity, right? And as you said, this is a huge problem, right? And that's why we are investing so much and actually merging so many solutions to solve parts of these problems. And what it comes to data-centric AI, so focusing more on the data-centric operations versus the model-centric, this is also a very broad term, right? And there are several hot topics under this umbrella, from data profiling, labeling, or synthetic data generation. So now focusing more on the academia side of things, what areas or subtopics are you focusing more with your students, or you see other research labs investing more? You want to start on that one, Stavros?
Sure. Yeah, happy to answer that. I think in academia, we need to provide them with a broader knowledge of how they apply these techniques. Of course, data-centric is important. The models, the algorithms, and MLOps and everything, those are tools. But the data and the business process and the business problem that we try to solve is actually what's more important. And that's what we try to teach students. In order to be effective, they can see that we can apply all these techniques, based on the conditions. And algorithms, you cannot apply it everywhere. If you do classification, you cannot apply regression algorithms, for instance. But they need to have, and that's what we try to do in my class, they need to have broad knowledge of different industries. So they learn the tools, they learn how to process data, how to get to a point that they can create a model, how to combine the model to generate insights and potentially in a report, a visualization. But we try to expose them to different industries. Healthcare, for instance, there's a lot of demand and a lot of research going on in applications. Customer experience being one of the top nowadays, because we believe in the next few years what will be the differentiator in competing companies will be the customer experience they provide more than the product they provide, if they provide similar products. Of course, finance and research areas. So we try to focus in different industries and pull in the assignments and the projects that they do, pull data sets from different areas that they can work on so they can gain experience, practical experience in the classroom, and then they can go wherever they're more interested to work on.
Yeah, well, can you hear me? Oh, yeah. And can you hear me? Yes, sorry. So yeah, I don't have I would say that it's probably that data-centric view. It's probably more prevalent when it really comes to putting things to work in practice. So I'd say it's something which is more important for companies than it is in academia. So when you're teaching students about machine learning and AI, essentially you focus a lot more on models and then on this more practical side of machine learning and AI. Although of course we have to make students aware of that. And in terms of research, let's say my experience with that is probably related to medical imaging. I have a couple of students PhD students who do medical imaging, and in medical imaging, is starving for data because it's very hard to get big data sets. And suddenly, with the advent of diffusion models, now the possibility is there to create synthetic data of very, very high quality. And so suddenly, it was almost unexpected. Like a year ago, I wouldn't have predicted it. It's possible to do something which is not very far away from what white data does, but for medical imaging, very high quality synthetic data. There's a group in London who's working on that, at least that one I know of Jorge Cardoso, and so sometimes these needs are met by a sudden innovation. Of course, if you look carefully at diffusion models, the underlying ideas have been around for a long time. It's Gaussian processes, it's core matching, it's all that stuff. But suddenly it becomes possible, and so yeah, we'll have to bring it in and to teach it to students too.
Yeah, so these are just all amazing topics, right? So from our side, so one thing that we have been kind of fascinated by is actually this interplay of data quality and model quality. Right. So if you look at the traditional data management as a field, right, so we have this really kind of different type of data quality issues, completeness, timeliness, accuracy, all those type of things, right? So there's a whole community of people who have been studying that for decades about how to deal with those. And now you put a machine learning model on top of it, right? And you train that model over this piece of data, and then you start to observe different kind of model quality issues, right? Like fairness or like robustness or low accuracy, something like that, right? So if you put these two things together, right, this data quality dimension and this model quality dimension, so one thing that we have been really fascinated by is how to link them together, right? So if you have this model with some model quality issue, can you just trace it back to the data quality side? What is the reason that this model have low quality? Can you do data cleaning? If you want to clean some data, acquire some data, fix some of your data, how can you prioritize your effort to really do that? So this connection, in my opinion, is actually very interesting. I have no idea how to solve it, but that's actually something we have been fascinated by in the last couple of years on the research side. Yeah,
that's definitely super interesting.
Understanding.
Go ahead.
If I may, we actually looking at that problem in collaboration with FIDSAI, with Peter Slave from FIDSAI, and a couple of master students on this issue that Chad just mentioned. This interaction, actually, in our case, more from the perspective of fairness. So, how do models and data interact to yield fair or unfair decisions in the end?
So I think that's just fascinating topic, right? So in my opinion, that's really one of the core, technical challenge of data-centric AI, right? How to link these two, right? Yeah.
Definitely. So do you think that this is the topic that you address mostly with PhD students and while doing research, but not at all when teaching classes? So based on your feedback, it seemed that classes are mostly about the basics of machine learning, how to apply some models and solve some typical problems, while these research on how data quality influences a model performance, this is more advanced topics, and it's usually addressed by PhDs. Is this understanding correct, or what are your thoughts on that?
Yeah, so in my opinion, right, so they start to have courses that try to link these two, right? For example, at Stanford, I know James and Mateo have this interesting course called The Value of Data, right? So try to link some of these dimensions together, right? So at ETH, we'll kind of start to try to build up some courses where the whole topic is how these two different players start to interact, right? So I think we are getting there, right? But of course, I think, in my opinion, there are a lot of things that we need to do on the academic side to really build up this high quality collection of courses to make sure students understand, in addition to model, there's data, and you can actually understand their connection in a principled way.
Mm-hmm.
All right. Anything to add, Mario or Stavros?
Well, yeah, from my side, in research, that's what I just meant. So in medical imaging, that's a very relevant problem, especially because of scarcity of data. Only really big groups in big places have access to reasonably sized data sets. Of course, there are public data sets, but in one of the difficulties in medical imaging is that all the problems are very different. If you're looking at brain or liver or something or knee, everything is very different. So you need specialized data sets. But in other areas, I don't have so much experience. So I would probably in teaching, as you said, Gonçalo, for now at least, teaching is mostly focused on models and standard stuff. So it is more applied, and it's usually all the projects that students do. Mostly they're based on public data sets, and we don't worry so much about that because, especially if you're teaching a course and the student has to do a project on a specific course, time is short, right? You have to do it in a few weeks. And so that constraint makes it a special type of work. You need to be sure that the student will be able to complete it in due time. So it shouldn't be too open.
I would agree.
All right. So picking up on something that you said before, Stavros, about the industry adoption and the problems that the private sector is bringing to the academia, can we elaborate a little bit on that? You mentioned customer experience; it's top of mind. But what other problems are the private sector bringing to academia and expected to be solved?
It really depends on the specific industry that a company works on when they work with academia. So, of course, there are opportunities. There's a lot of transformation that happens across many sectors in many companies. They try to adapt these technologies. I would say, with respect to areas that there will be a lot of more work in the near future, because it's hard to predict at this exponential rate what will happen in 5 years. But in the next few years, there will be a lot more convergence in terms of how we solve language. And I know we have a lot of solutions with the transformers and the GPTs and all these other recent developments, but they required a lot of computing, a lot of training data, and we're still not at the point that they can generalize very well. So I think we can expect to see NLP, language processing, and all subfields, subtopics to progress quite a bit, and then it will become a little bit like plug and play. And data quality is important everywhere. So this needs to be stressed. How do we deal with data quality? Of course, data synthesis can be part of the answer. The other area of interest, I would say, explainability. Especially advanced models, it's hard to explain how they come up with the solution. So explainability in a way that the business or a regulatory committee can understand and accept is important. And again, going back to model generalization, when you build a model, it could be biased depending on the data that the predictions provides or the output provides. It can be biased depending on the data. So students need to understand that they cannot just go and apply an algorithm to the data. They need to understand what will come out of it and potential bias in the outcome. Of course, as was mentioned before, I think Chen mentioned this, drift. We need to be aware of data and model drift. It's part of the game. So we try to teach students that this type of probabilistic technologies that we work with in machine learning, you don't just build something and put it on the shelf. You need to maintain it and have your proper MLOps and DevOps planned ahead. So I'm not sure if I'm answering fully your question. If you're looking for something else, one more last thing about subtopics: low code or no code. There's a lot of talk about that. You have a solution, you don't have to do any coding. We're not yet at the point that no code will help you build an industry, strong type of solution you can use for quick experimentation, but you still need to know what you're doing. And that's what we stress in academia. You need to understand the basics. You cannot take an online machine learning class for 2 months and say that you can really apply this to create a sustainable solution, a scalable solution. So those are my thoughts in what you ask. I'm not sure if I'm answering fully, or if you want to elaborate a little bit more.
Definitely. No, we just wanted to hear what kind of problems the private sector is bringing to the academia. So that is great. So you mentioned from data quality to explainability, bias and fairness, as well as looking for no code or low code solutions. So that's exactly very hot topics at the moment. So the input was great. Looking forward to your comments as well, Mario and Zhang.
Yeah, so I'd probably add, so I agree with everything that Stavros said. Those are good points. I'm not going to repeat. I would also probably add that in addition to just the standard private sector, we have a lot of demand for collaboration from other areas like healthcare, but not necessarily private, from hospitals, from institutions such as, say, city councils or organizations such as that have a lot of data. For example, the Lisbon City Council has a lot of data on bike mobility and stuff like that, and they want to optimize something. And there's a lot of demand from outside of the traditional areas where people know how to use these tools. And so these low code and no code things are probably relevant. I'm a bit skeptic about low code and no codes, in the sense that it will be like a general purpose tool, like your grandmother can use to help her choose what she's gonna watch on Netflix tomorrow by mining users' preferences. But I think it is important. It's really important for a tool for someone who knows what he's doing, but there's one to waste too much time writing code and just wanted to prototype some at least some preliminary attempt and to explore possible ways of solving the problem. But this promise that everybody will be a data scientist using no-code tools, I don't believe in that. So I think it's important to have user-friendly development tools, but I'm a bit not so enthusiastic about that wide applicability. What was the other topic? I forgot what you were mentioning.
Yeah, we have been discussing data quality, explainability, fairness and biases.
Yes, explainability and fairness and bias. That's for me. It's a very prevalent topic because of my collaboration with DCAI. It was a financial fraud detection company where they pay a lot of attention to fairness and explainability, both for regulatory reasons and because of company policy. They want to be very fair and want to be very transparent. And so that's one of the areas where I've been collaborating with them. And I'm sure it's the same. Also in medical applications, it's extremely important. So those are things that are showing up. And we talk about it. We have this new deep learning course at IST, and that's one of the topics we covered in the last lecture. Is about explainability, fairness, and all that stuff.
Yeah. So just want to echo like some of the previous discussion about low code, no code, and how. Yeah. So like on that topic. So definitely agree with everything has been said. So one thing I think that's interesting coming out of this collaboration of industry and academia in the next couple of years is actually how to make building high quality means fairness, explanation, right? So also like accuracy type of thing, as systematic as possible, right? So I think right now the community is very good at building some machine learning applications if it's really important. But on the other hand, how can we really make that as boring, as systematic as possible, right? If you look at developing traditional software, there's a whole bunch of design patterns, there's a principle of software engineering to really give people the guidance about how to think about different problems, how to think about different pitfalls, what are the things that you should not do in developing that. So I think what's actually interesting right now is we don't really have that for machine learning, right? So hopefully in the next couple of years, we can actually bring some of the idea from the traditional software development into machine learning to make that process kind of standardized, systematic. We know how to test. We know how to convince ourselves the whole thing is working, right? So not have make everyone a data scientist, but to make sure those people have this principle framework to actually reason about that. Yeah. So I think that could potentially be interesting, in my opinion.
Mm-hmm. Definitely. I totally agree on that one. Well, as for my last question, as the time is running up, this one is actually very, very easy. So today we have an audience of startups, companies, and communities of data scientists. And the question is, how can they be more engaged with you and help academia foster innovation in this space?
Yeah, so I think that part, like in my opinion, is continue to do whatever guys you have been doing, right? Just come to us with challenges that you are facing that you hope, in 5 years, wouldn't that be nice if someone figured out how to do that, right? So that collection of problem and challenges, to us, is just really fascinating, can give us guidance about what to look at. Also, what type of leader that we could produce for the next generation, right? Yeah.
Right.
Yeah, I totally
bringing
agree.
Problems to you.
I totally agree. Problems and ideas, not only problems. So the traditional view is that companies bring problems, academia solves it. I have a more symmetrical view because there's also a lot of problem-solving ability in companies because people have the hands-on experience and the knowledge. And so I think it's a very synergistic interaction between academia and companies. I think it's been very fruitful at IST. So we in many different ways. We have lots of master theses which are done in co-supervision between someone from academia and someone from a company, addressing a specific problem that the company wants to see solved, but which also has some scientific contribution that can lead to publications. And we see that we go to the best machine learning companies nowadays, and we see a lot of publications originating from either from companies only, from research labs from companies, and a lot of publications, a lot of advances in methodologies and at the cutting edge of the area from interactions between academia and companies. So it's clearly being fruitful.
And to that, I would add that, you can see a lot of research publications, and you can even take, if you're a student or a startup founder, you can take a paper and create a company out of that. But what's really important comes down to again to the experience. And I would say what I say to startups and venture capitalists that I provide advisory services to. I would say focus on the experience and the specific problem that you solve. You can create models, but if you don't package it in a way that's easy for people to use and you just focus on the technology, then maybe you don't have a company. People will not use it because somebody else will come with the same idea and package it better. So make it easy to use, and the innovation is inside. The smarts are inside in the solution that the startup will be working on. But it's important to provide a very good experience, and this part of the innovation in those startups that will allow them to flourish or more. And we see this. We see all the data companies, so the largest capital companies. They're just data driven. You see all these new industries, the Ubers, the Airbnbs, even Google. It's just data, but they package it nicely. It's easy to use. They provide a positive experience in most cases. And that will be the differentiator. That's part of the innovation, because there is a lot of marketing out there. There's many companies that they claim they do something. When you look under the hood, either you cannot use it or they don't really do it. They just put the AI label because it's popular nowadays. So that's what we try to tell our students to focus on the idea, but not only on the technology, on how to make it usable. And I bring this, as I said, to VCs, this type of specific advice when we're going to the details, when we evaluate a startup. And it comes from the experience. I didn't start as an educator. I'm only working at NYU as a professor, even though I taught in other places for the last 8 years. And I've come from the industry. And I appreciate that we're in this panel, very interesting topics. This is my personal views based on my industry experience and also teaching at university. So thank you for the opportunity again.
Of course, and thank you. And I think this sums up our panel today. So let's give a big thank you to our panelists. And in case you have follow-up questions, post them on the community Slack so he can back to you. And well, thank you so much, says Stavros and Mario. And well, see you soon.
Thank you for the invitation. Bye-bye.
Thank you.
Thank you. Bye.